So once again, so your home plate for tonight. Oh, and by the way, as you're copying it down, leave 3 blank lines per question, 2 or 3, depending on how you write your answers. So like that, you don't have to give me the work in the backside or anything like that. So for number 1, it says, in your own words, define zero pairs or the additive inverse property. Step 2, or number 2, in your own words, define the identity property of addition. Number 3, represent a zero pair using tiles and describe it in your own words. Number 4, represent -7 plus 12 using tiles and zero pairs. Describe your number in your own words. So that's your home plate for tonight. So that's our home plate. So let me do a quick recap as to what we've seen so far these couple of days. I left you a home plate for you to view a video. Is that correct? And in the video, it showed about digging a hole and stuff like that, right? So here, this could be a question for that scenario. If I dig a hole 7 feet deep, how much dirt do I need to cover the hole? So when it's flat, what did we call that? Ground zero, okay? So here's me, bam, muscles and everything, and there's the hole right there, and that's 7 feet deep. So if I dug all this dirt and it's over here, how much dirt do I have over here? 7 feet. That is correct, 7 feet. So now, some terminology once again. This has no dirt. The word no is a negative, isn't it? Yes. Kind of like when you ask, oh, can I go to Johnny's? No. So that's a negative, so therefore this is -7. Over here we do have dirt. It's yes. That's a positive, therefore this is a what? A +7. And that's how we get -7 and +7. And we said that that was equal to 0, and it gave us ground zero. Is that pretty clear as to what we saw in the video? Yeah, right? Okay, so that leads us to today's lesson. So today's lesson is the following. The objective, I can define and represent integers using integer tiles and zero pairs. I can define and represent integers using integer tiles and zero pairs. Let's read it together. 1, 2, 3. I can define and represent integers using integer tiles and zero pairs. So by now you should have already copied that objective at the bottom left of your Cornell note. Is that correct? Now the question that I would ask from the objective would be, what is the concept for today and what are we doing with it? So, question, what is the concept for today? Tell your neighbor what the concept for today is. Concept for today. And by now some of you already identify the colors, right? Very simple. So the concepts were what? Integers and zero pairs. And what are we doing? We're defining and representing. Since we already know what zero pairs are because we saw it on the video, let's clarify what integers are. So in your Freyer model, in here, you're going to write integers and write this definition. Here we go. Definition, integers. Integers are whole numbers including their opposites. That's simple. Integers are whole numbers including their opposites. 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 Tell your neighbor the definition, please. Wow, you guys are pretty good. So, the only thing now is we need to clarify what each part of the definition means. Does that make sense? So, here in the examples, I want you to draw a number line, like so. And let's clarify what each of these parts mean. So we need to understand what integers are. So to understand what integers are, we need to know what whole numbers are. Whole numbers are counting numbers. So let's first write the counting numbers. 1, 2, 3, ... to positive infinity. However, it should include the number 0. These are whole numbers. Counting numbers including 0. Does that make sense? Yeah. Is it clear? Yes. So whole numbers are counting numbers including 0. There it is. But for integers, the whole definition says integers are whole numbers including their opposites. So tell your neighbor the opposites of all these. Exactly, all the negatives. So -1, -2, -3, ... to negative infinity. And guess what? Now we have integers. All of these together are integers. But from 0 to the right, what are these called? Whole numbers. Are we there so far? Okay? So, let's see. Is 12 an integer? Yes, write it in there. How about 155? Yes. How about -28? Let's see. Will -28 be able to be plotted here? Yes, it's somewhere over here. How about -267? Yes. So any of those are integers. Okay? So now that we know what integers are, the other question is going to be what are not, or what other things or numbers are not integers. So here they are. Copy those. As you're copying those, answer the question to yourself. These are not integers because blah, 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 blah. And some of you already got it, right? Yes, Mr. Q. All right, good. Copy that. Questions. Why are these examples of integers and why are these not? Talk it over with your neighbor. Why are these integers? Why are these not? All right, let's see. So now that you talk it over with your neighbor, now imagine that your BFF is not here, right? And they do have this class. So let's say they're not here, but they do have this class. And later on, they either kick you or Snapchat or Instagram you or whatever. And they're like, hey, what are we doing, Mr. Q? You're like, oh, we covered integers today. Yeah, what's that? What would be 3 simple words that you would tell them integers would be? That would clarify what integers would be. Tell your neighbor. 3 simple words. Okay, who can give me the 3 words that we're looking for? Or give me some words. Let's see. Tony. Whole numbers. Whole numbers. So that goes here in the critical attributes, right? Whole numbers. And to clarify that, in parentheses, just write no fractions or decimals. And what is the other word? Yeah, whole numbers include 0. Okay. Good. Yes? Counting numbers are included in whole numbers. Yes? Opposites is the other word that we're looking for. Opposites. Very good. And that's how you write the critical attributes. And by the way, welcome, guys, to the Frayer model. This is how we're going to do the Frayer model the entire year. We're going to use it to clarify the main concept before we get started with doing anything in there. Did that help? Yes, right? It clarified totally what integers are. So therefore, definition, examples, non-examples, and here are critical attributes. If you still don't understand what critical attributes are, kind of like this. If I was to write here Mr. Q in the center, what are the main things that make up Mr. Q? Well, he's an awesome basketball player. Bam. He dances better than Usher. Bam. He loves math, right? I love teaching math. And what else? I like walks at the beach. And anyways, you get the idea, right? The main concepts that makes the definition of whatever we're talking about. So now here goes the next part. The next part I'm going to require for you guys to think, and you're going to come up with the property of the additive inverse property. So check this out. Here's your Frayer model on your paper. Underneath the Frayer model, write this down. Additive inverse property. Additive inverse property. A plus negative A equals 0. 7 plus negative 7 equals 0. Negative 15 plus 15 equals 0. 0 equals negative 2,500 plus 2,500. Copy that. So, now that we wrote that down, and again, you're still talking to your BFF. Some of you are gamers. You're on your PS3 and you're texting back and forth, right? And they're like, what else did you guys cover? Oh, we covered the additive inverse property. Oh, really? What is that? I don't know how, I can just say that it's 2 plus negative 2 equals 0, or negative 5 plus 5 equals 0, 100 plus negative 100 equals 0. But he told us to come up with a definition for that. So what would be a rule or a definition to explain this to your BFF? Think about it. What would be a definition, generalize the idea in words to explain the additive inverse property? Talk it over with your neighbor. How would you generalize that idea? Okay. Who can get us started? Let's see. Yes, sir.
Any number and their opposites equal 0?
Say a little bit louder, please, for everyone.
Any number and their opposites equal 0?
He said any number and their opposite equal to 0. Let's see. Here I only used integers. Let's try with any number. Let's see. Would it work with decimals? Let's see. 0.25 plus negative 0.25, is that equal to 0? Yeah. How about 3/4 plus negative 3/4, is that equal to 0? Yes. So does that definition work? What do you guys think? Was that something you guys were thinking about? Okay, write that down, please. Additive inverse property, and write that definition. Let's see, what would you write? Okay, Tony, can you repeat what you wrote?
Any number plus its opposite equals 0.
Okay. Is that pretty much what you guys wrote? Yes? Okay, that is true. Any number plus its opposite equal to 0. I wrote, in my words, I wrote a number and its opposite add up to give 0. It's pretty much the same. Yes?
Yes.
All right. Next, underneath that, I want you to write this next one. Identity property of addition. Identity property of addition. If it doesn't fit, turn your paper over, do it in the back. So, here we go. A equals 0 plus A. 7 equals 0 plus 7. Negative 10 plus 0 equals negative 10. 1,000 plus 0 equals 1,000. By now, you already know the identity property of addition. So let me ask you this. Underneath that, I want you to write your own example here. Write your own example. These are my examples. I want you to write your own. If you're writing your own, that means that you understand the property. Is that correct? Yes, Mr. Q. All right, good. So once again, later on at night, your BFF kicks you, and you're like, oh, what else did you guys cover? Oh, the the identity property of addition. What is that? Tell your neighbor what you're going to tell your BFF. What is the identity property of addition? All right, and for this one, I'm going to select someone since we already know, we already got the hang of this. How about Ryan? Say a little bit louder, please. He said any number plus 0 equals that number. Do you agree with that? Write that down. Bam! On the first try. Okay. Copy that, please. Write it down. Okay, underneath that, I want you to copy example number 1. Write this down. Show a zero pair using algebra tiles. Show a zero pair using algebra tiles. Show a zero pair using algebra tiles. -7 plus 7. So now you have a little baggie of tiles in front of you. Get those out, please. And I'm going to get my camera. Let's see. Bam. There it is. I'm telling you, I got this. So, it says here, let's show zero pairs using algebra tiles. So what is the first number that we need to represent? So let's get 7 negatives in front of us. We got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. What is the second number? +7, so I got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, so now that you have that on your desk, on your paper, this is what I want you to write. Next to here, you're going to leave a little space, and I want you to draw the tiles. 1, 2, 3, 4, 5, 6, 7. How many +7? 1, 2, 3, 4, 5, 6, 7. Circle those. Cross them out because they're called what? Zero pairs. And here on this expression, you're going to write equal to 0. Does that make sense? And now we are actually using the additive inverse property, right? A number and its opposite equal to 0. Okay? We got this so far? Okay. Copy example number 2. See if you can do this one by yourself. Example 2. It says, show a zero pair using algebra tiles, -3 plus 3. Copy that and do that one by yourself. Go. All right. Some of you did this. Watch. Some of you had this, and all you did is you removed 4 of these. Is that correct? And that left you with 3 and 3. So therefore, how would we write that? We would write 1, 2, 3, 1, 2, 3, circle that, and this is equal to 0. So far, so good? Now, before you take these tiles away, check this out. It says here, represent -1 using algebra tiles in zero pairs. Now, look what I have right now on my desk. I have these. Tell your neighbor what I need to do to this in order to represent -1. Tell your neighbor what we need to do to this to represent -1. All right, I heard somebody, you can add a negative like this. Is this -1? Yes. Yes, because this is 0, and we're left with -1. How about could I have done this? Yes, because it's still 0 and -1. So therefore, for tonight, I want you to answer those 4 questions and see how you do. Put away the tiles, log off from Nearpod. Have a good one, guys. Enjoy those 4 problems for tonight. See you guys tomorrow. Bye.